Hi dear students, welcome back to the session. Last class we discussed about capacitance of parallel plate capacitor without any dielectrics between the plates of a capacitor. I guess you remember the construction of parallel plate capacitor. It consisting of two thin metal plates, and one of the plate is charged positively and another plate is charged negatively, and those two plates are placed very close to each other in such a way that whatever the gap which is existing between the two conducting plates of a parallel plate capacitor was not filled with what? Any dielectric medium. That is, this is the first plate of a capacitor, first rectangular plate of a capacitor, and this was the second plate of a capacitor, and one of the plate is charged positively, and another plate is charged negatively, and each plates have the surface area, that is A, and these two plates are separated by what? Distance D, and whatever the gap which is existing between the two plates of parallel plate capacitor was not filled with what? Any dielectric medium. Either air is considered as a dielectric medium, or else the vacuum may be present between the two plates of what? The parallel plate capacitor. If that was the case, capacitance of parallel plate capacitor is given by C is equals to epsilon naught A divided by D. Concentrate on this expression. This is the expression for capacitance of parallel plate capacitor without using any dielectric medium. So already you know very well, A is called area of the plates and D is called distance between the plates. If I ask you the question, mention the factors on which capacitance of a parallel plate capacitor depends, your answer is capacitance of a parallel plate capacitor depends on area of the plates, and it also depends on distance between the plates. But in this session, let me discuss about capacitance of same parallel plate capacitor when you are using some dielectric medium between the plates of a capacitor. Let me consider the next session here. That is capacitance of parallel plate capacitor, capacitance of parallel plate capacitor with dielectrics. So write down the next heading here: capacitance of parallel plate capacitor with dielectrics. So the discussion, as per the discussion, I will consider the two plates of parallel plate capacitor. This is the first plate of parallel plate capacitor. This is the second plate of parallel plate capacitor. First plate is charged positively. Second plate has equal negative charge, and these two plates are separated by what? Distance D, and it is charged positively, therefore its surface charge density is sigma. It is charged negatively, therefore its surface charge density is minus sigma, and each plates have same area, that is A. Okay, then in this case, whatever the gap which is existing between the plates, that gap is filled with what? dielectric medium, any dielectric medium of constant, that is dielectric constant K. Now I am filling the gap between the two plates of what? Parallel plate capacitor with some dielectric medium of what? Dielectric constant K. Very simple here. When you use any dielectric medium between the plates of what? Parallel plate capacitor, its capacitance is going to increases. The reason is, if you use any dielectric medium between the plates of a parallel plate capacitor, that capacitor will start storing the more quantity of charge, that is charge stored by the capacitor increases. When the charge stored by the capacitor increases, its capacitance is also increases. So try to give the answer for my question. What is the effect of dielectric medium for capacitance of a capacitor? What is the answer? Capacitance of a capacitor increases when you are using dielectric medium. Now I will write what it is. Capacitance of capacitor. Which capacitor? Parallel plate capacitor. Capacitance of parallel plate capacitor when dielectric medium of dielectric constant. Capacitance of capacitor when a dielectric medium of dielectric constant K is filled between the plates. Between the plates. Okay, what is the capacitance? Capacitance is given by, I will call this as C dash. C dash is a capacitance of a parallel plate capacitor when you are using which medium? Dielectric medium. That C dash is given by what? K into epsilon naught A by D, which is an expression for capacitance of which capacitor? Parallel plate capacitor when you are using some dielectric medium of what? Dielectric constant K. Then what is epsilon naught A by D here? What is epsilon naught A by D? Epsilon naught A by D is called capacitance of a same parallel plate capacitor without using any dielectric medium. If that is the case, what I can write? Next, C dash can be written as K times C. C dash can be written as K times C. Then what is C here? What is C? Yes, where C is equals to epsilon naught A by D is capacitance without any dielectrics. So where C is equals to epsilon naught A by D is a capacitance without dielectrics. Look at the relation here. What is C dash? C dash is a capacitance when you are using dielectric medium. C is a capacitance when you are not using the dielectric medium. What is the relation between C dash and C? Capacitance of a parallel plate capacitor increases. K times the capacitance of a what? Parallel plate capacitor in air medium. Means if you use any dielectric medium, its capacitance, that is capacitance of parallel plate capacitor increases how many times? K times the capacitance of same capacitor in the air medium. See, for example, you have a parallel plate capacitor. Imagine you have a parallel plate capacitor of capacitance around 50 microfarad. you have a capacitor, that is parallel plate capacitor of 50 microfarad. Imagine that I have placed some dielectric medium of dielectric constant 2 between the plates of this parallel plate capacitor. Then what happens to the capacitance? As I said you, capacitance increases K times the what? Capacitance in air. Capacitance in air was how much? 50. When you use dielectric medium of dielectric constant 2, then what happened to the capacitance? Capacitance will be K times the initial capacitance. What is the value of K here? 2. 2 into 50, how much it is? 2 into 50, of course, 100 microfarad. So, in general, the concept is, whenever if you use a dielectric medium between the plates of a parallel plate capacitor, what happens? Its capacitance is going to increases. Let me write a conclusion here. Concentrate on the conclusion. Capacitance of which capacitor? Parallel plate capacitor. Parallel plate capacitor increases K times when we use dielectric medium. So its capacitance increases the K times. What is K here? K is called dielectric constant of a medium. K stands for dielectric constant of a medium. Okay, this is how the capacitance changes when you are using dielectric medium between the plates of what? The capacitor. Okay.